notes part 2. I just want to back up a second and look at where you're at. So we did this problem on at the end of the last section, talking about the landscaper. So we looked at the data. We came up with, can we realize kind of what we're dealing with here? So he can only do 3 landscape jobs per day, and he can mow as many times as he needs to in a day. So we came up with some inequalities, graphed them, figured out our feasible region, the region that makes the most sense, or the region that's within all of our limits. And then we figured out kind of what maximized his profits. So if we kind of back up a little bit. So if we've got this set of data, y greater than or equal to 2, x is going to be between 1 and 5, and then y equals x plus 3. So we want to look at that data, and then we want to find the maximum and the minimum for those. All right, so y greater than or equal to 2. So here's 2. So it's going to be a solid line. Greater than means I'm going up. X is going to be between 1 and 5. So that means it's going to be 1, 2, 3, 4, 5. So that means I want to shade inside here. And then this last one, y less than or equal to x plus 3. So there's x plus 3. There's 3 right there. So I want to go straight up this way. And then I'm going to see, do I shade 0 less than or equal to 0 plus 3? Is 0 less than or equal to 3? Yes. So that means I'm going to shade down and in. So now, where does all that overlap? Well, all that overlaps right here. So there is my feasible region. Now, what I want to look for is what are the corners or what are the vertices of that feasible region. Now here, this one I got to kind of guess. So it's going to be at 5. This one's going to be about 5, 8. Okay, so you got to kind of use your heads here and think about this. So my points are going to be 1, 0, 5, 0, 1, 5, and 5, 8. So these are going to be the points, the corners of my feasible region. So 3x minus 2y, so 3 times 1 minus 2 times 0 is going to be 3. 3 times 5 minus 2 times 0 is going to be 15. 3 times 1 minus 2 times 5, that'll give you negative 7. 3 times 5 minus 2 times 8 is going to give you negative 1. So now, what's my maximum, what's my minimum? Well, my maximum here is going to be 5, 0. My minimum here is going to be negative 7. And again, all I did was put all of my values into the objective function, 1 for x, 1 for y. So take a look at this one. X plus y equals 2, 4y is less than or equal to x plus 8, y is greater than or equal to 2x minus 5. So here's kind of the situation. If I rewrite this, y greater than or equal to negative x plus 2, all I did was subtract x over. So plus 2 get a good line there. Does 0, 0 work? Well, even if I put it in here. Is 0 plus 0 greater than 2? No. 0, 0 doesn't work. Shade away from that. All right, so I'm testing 0, 0. So 4y less than or equal to x plus 8. Divide everything by 4. So y is less than or equal to 1/4 x plus 2. So let's change colors here. So I'm at plus 2. That's going to be up 1 over 4. And that's going to be my slope. So now, is that going to be true here? Well, is 0 less than or equal to 1/4 times 0 plus 2? Is 0 less than or equal to 2? That answer is going to be true. So I want to shade down this way. So far through 2, This is my only area in here that I got to shade. For the last one, y greater than or equal to 2x minus 5. So I'm at negative 5, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. It's going to look like that. And so I want to look at where is my feasible region. So let's test 0, 0 here. Is 0 greater than or equal to 2 times 0 minus 5? Is 0 greater than or equal to negative 5? Yes. So I'm going to shade this way. So my feasible region is right about here. Just this little itty bitty triangle. So I've got 0, 2 is one point. I've got 4, 3 is another point. And then this one looks to be about 2.5, negative 1/2. So I'll go 2.5, negative 0.5. So now maximize, minimize. So 4x plus 3y. Let's see what I get. So 4 times 0 plus 3 times 2. That's going to be 6. 4 times 4 plus 3 times 3 equals 16 and 9. So that's going to be 25. Then 4 times 2.5 plus 3 times the negative half is going to equal 10 minus 1.5. So that's going to be 8.5. So this one doesn't even really matter because this one's my minimum and this one's the maximum. Okay, so let's do one more and then I'll stop. Clothing company makes jackets and pants. All right, jackets and pants. Those are two things we're dealing with. So I'm going to call the jackets the X and the pants the Y. Each jacket requires 1 hour of cutting and 4 hours of sewing. Each pair of pants requires 2 hours of cutting and 2 hours of sewing. The total time per day available for cutting is 20 hours. The total time for sewing is 32 hours. Or let J represent the number of jackets and P represent the number of pants. And then write a system of inequalities to represent the number of items that can be produced. So all we're looking for is my system of inequalities. So we have jackets and pants. So now we need to think about this in terms of cutting and sewing. All right, so for the jacket requires 1 hour of cutting and the pants requires 2 hours of cutting. So for cutting, it's 1 hour for the jacket and it's 2 hours for the pants. For sewing requires 4 hours for the jacket and it requires 2 hours for the pants. So right now there is kind of a representation of how long it's going to take, how many hours it's going to take to cut and sew jackets and pants. So now here's where that second piece of information comes in. The total time per day is 20 hours for cutting and 32 hours for sewing. So that means cutting has got to be less than or equal to 20 hours. Sewing has got to be less than or equal to 32 hours. All right, so that's going to be my system of inequalities. Plus, you know, the fact that I got to make at least 0 pairs of jeans and, or at least 0 jackets and at least 0 pair of pants. But those are kind of understood. Okay, come talk to me with questions. This is not an easy concept. This does take a lot of thought and you've got to work through it. So come talk to me and let's get this figured out.